Okay, now that we have our forecasting equation, okay, let's look at the next question. So here we want to determine the coefficient of correlation and the standard error of the estimate. So coefficient of correlation, that is R, is given by the formula n times sum of x times y minus sum of x sum of y. Okay, that's the numerator, and then in the denominator, okay, it's a square root of, there are two parts to this, n times sum of x squared minus sum of x, the whole thing squared. So that's the first part, and then you do the same thing for y. That gives us the correlation coefficient. So from the previous page, we already have all the information that we need, okay, here. So R is, you have to just simply plug in. So n is 8 times x times y, sum of x times y, so that is 255.44, and minus sum of x is 135 times sum of y is 14.13, and in the denominator we have 8 times sum of x squared, which is 2445, minus sum of x squared, 135 squared. So that's one part, and then we have 8 times sum of y squared, which is 26.8099, minus sum of y, which is 14.13 squared. So this whole thing, okay, so like that. And when you work this thing through, you get 0.9666. Now when you square that correlation, what we get is coefficient of determination. That is 0.9666 squared, which is equal to 0.9343. Now, the next item that we need to determine is standard error of estimate. And the standard error of estimate is given by S sub y dot x, and that is square root of, well, sum of y squared minus a times sum of y minus b times sum of x times y over n minus 2. So that is equal to, and once again we have the information already from the previous page. So sum of y squared, which is 26.8099, minus a is 0.0484 times sum of y, which is 14.13, minus b is 0.1018 times sum of x times y, which is 255 0.44, and this divided by 8 minus 2, n minus 2. Now this whole thing is under square root, and this is equal to 0.1427. So that is standard error of y estimate.